Alright, today we're solving absolute value inequalities. Remember that absolute value is a number's distance from 0. So 5 is 5 away from 0, and negative 5 is 5 away from 0, right? So if you're keeping in mind distance from something, today we're bringing in absolute value with inequalities. So if the absolute value, its distance, is greater than something, it would be further away, right? And what kind of graphs go towards the outside? Or, oh my gosh, the or compound inequality. So if you have the absolute value and it's greater than something, it's going to be an or type of problem. And if it's the absolute value and it's less than something, the distance is closer, so it would shade in the middle. So if it's less than, then it's going to be an and type of problem. But first, you always have to isolate the absolute value, which most of the ones they're going to give you are already isolated. So let's try this one now. Absolute value of v minus 3 is greater than or equal to 4. So it's greater than. The distance is further away. It's an or type of problem. The first step is always going to be the same. Just write it without the inequality or with the absolute value symbols. So it would just be v minus 3 is greater than or equal to 4. But again, we said this is like an or type of problem. So we'll say or v minus 3. And here's the trickery. We're going to flip the inequality, and we're going to make the answer the opposite version of the answer, so negative 1. And that's the same thing we did with the equations. We just said, okay, well, v minus 3 equals 4, and v minus 3 equals negative 4. But now we also have to flip that inequality sign. So we solve them both. They're both going to have the same step, plus 3, plus 3. So we end up with v is greater than or equal to 7, or v is less than or equal to negative 1. We graph them. On a number line, negative 1 would come first. And negative 1, they both have solid dots. Numbers less than or equal to negative 1 are to the left. Greater than or equal to 7 are to the right. So anything that is shaded would work in the initial inequality. So if I chose a number like negative 10, which is shaded to the left here, and I put in negative 10 minus 3 is negative 13. The absolute value of negative 13 is 13, which is greater than 4. Anything in the middle that's not shaded, like 3, will not work. 3 minus 3 is 0, absolute value of 0 is 0, and 0 is not greater than 4. So again, this shows you all of the solutions that do work. So if we tried w plus 2 is greater than 5. Again, it's greater than, further out, it's an or type of problem. So first time we'll just drop the symbol. W plus 2 is greater than 5. Or w plus 2, flip the sign, make it the negative version of the answer, negative 5. It's kind of like we took that right half of the equation and multiplied by negative 1. So we'll subtract 2 from all of this. W is greater than 3, or W is less than negative 7. Negative 7 would be to the left on a number line because it's smaller. Open dots on both of them. With all of these, the dots are going to be the same. And shading towards the outside. Part B, what are the solutions of the absolute value of W plus 2 is greater than negative 5? Can something have negative distance? No. So just like if that was equal to, it would say no solution. Same thing here. You can't have the absolute value be, well, actually that's not true. You can't have it be less than negative 5. So if you were to set up two equations here, you could say W plus 2 is greater than negative 5, or W plus 2, flip the sign, less than positive 5. So making it the opposite there. Let's see. So minus 2, W is greater than negative 7, or if we subtract 2 here, we get W is less than 3. But let's see what this looks like if we graph it. So these would be open dots, and it would shade in the middle. But let's pick a number like 0. 0 plus 2 is 2. Absolute value of 2 is 2, and 2 is greater than negative 5. If I were to pick something like negative 50, which is not shaded, negative 50 plus 2 is negative 48. Absolute value of negative 48 is positive 48. So that also works, but it's not shaded. So this one's weird because absolute value always comes out positive, and every positive number is greater than negative 5. So this one would actually be all real numbers. There's a little bit of trickery there. So absolute value is always going to come out positive, so it's always greater than any negative number. Now, if that was the absolute value of this is less than negative 5, that's not possible, so you'd write no solution if that happened. We just have some that we're going to try here. Now, when it is less than, I'm trying to remember what the next slide looks like. Yeah, we'll go to the back side here. When it's something that is less than, it's going to turn into an and type of problem. So number 27, again, it's isolated, so just drop the symbols. But remember with and problems, there were kind of two inequalities mushed into the same one. So when it's an and problem, you could do what we just did and say and y minus 2, flip the sign and make it negative 1. Or if you know that it's an and problem, you could just throw another inequality over here and make the negative version of the answer. So we put a negative 1 over there. It's the same thing as if you wrote two separate inequalities. So here we would just add 2 to everything. Negative 1 plus 2 is 1. In the middle we have y. Over here we have 3. 1, 3, both closed dots and shaded in the middle. So anything between 1 and 3, and including 1 and 3, should work. If we try 2, 2 minus 2 is 0. Absolute value of 0 is 0, which is less than 1. If we chose any number less than 1 or greater than 3, it's not going to work. If we chose 4, 4 minus 2 is 2. Absolute value of 2 is 2, and 2 is not less than 1. So let's try to find a terrible one that shows a less than sign. 49 is pretty rough. Interesting. Let's go to 51. Shall we? We shall. I gotta make a little more room here. Now, number 51 is initially showing that it is greater than, maybe, but remember we have to isolate those absolute value symbols first. So first we would subtract that 4 to get rid of that. Which will give us negative 3 times the absolute value of m plus 2 is greater than negative 18. And then we have to get rid of that negative 3 in front. It's being multiplied, so we'll divide it. Which will give us the absolute value of m plus 2. But oh, we divided by a negative, flip the inequality. So now it's less than positive 6. So we'll drop the symbols. M plus 2 is less than 6. And because this is an and style of problem, because it's less than, we're just going to throw negative 6 over here. And then to all three sides, we're just going to subtract that 2. Negative 8 is less than m is less than 4. So anything between negative 8 and 4 would work in the initial equation. But of course, it doesn't include those numbers because it's not the or equal to. There we go. So it's just practice, it's repetition. Less than and type problem. Greater than or type of problem. Cool? Let's try some.